Okay, so we want to look at simplifying expressions, okay? So before we get into the expressions, we want to look at term. So a term is a number or product of a number and variables raised to power. So here we have some examples of terms. So negative y, 2x cubed, 5, 6xy squared, right? All of those are considered terms. On a term has a coefficient, also called a numerical coefficient, okay? Well, the numerical coefficient is the number that leads the term. So in the example, negative y, the leading coefficient is a -1, okay? So anytime you don't see a visible coefficient, it is an assumed 1, and then that negative means it's -1. So in the term 2x cubed, the numerical coefficient is 2. In the term 5, well, it's just a 5. There's not even a variable component there. 6xy squared, the numerical coefficient or just the coefficient is 6. For the term x, the coefficient is 1, right? So remember, anytime you have a variable that does not have a visible coefficient, right? These are visible coefficients. It is always an assumed 1, okay? So we have algebraic terms can and often should be combined and simplified. So only terms that are alike can be combined. So when we simplify, I had to erase. So when we simplifying algebraic expressions essentially means to combine like terms. So vice versa, combine like terms means simplify, and simplify means to combine like terms. All right, so they just go back and forth. So directions could say simplify, or directions could say to combine like terms. But as we move forward, our directions will just say simplify. So when we have terms, we want to be able to identify ones that are like versus ones that are unlike. So if terms are like, they have the exact same variables in each of them. All right, so basically they have the same variables and exponent values in each term. So let's look and compare some terms so that we can determine if they are like or unlike. All right, so 3x cubed and 2x. So those would be considered unlike because like terms must have the exact same variable and exponent values. So what you do is you should look at everything that is behind the coefficient. If you look at everything behind the coefficient, they should match exactly. If they don't, they're unlike terms, okay? Next, 4x squared y, -2x squared y. So everything behind the coefficient, right? So x squared y, x squared y. So since they match exactly, those are like terms. All right, behind the coefficient. So we're comparing y squared to y squared. So what's that mean? That means like. All right, let's look at this. 6ab -4ba. So one thing we want to pay attention to is anytime you're trying to compare terms, you should always have the variables in alphabetical order so that the variables match so that you can really be able to see if they're like terms or not, okay? Because multiplication is commutative, so BA is the same as AB. But we want to write it that way so that we don't get confused. So AB, what does that mean? It means these are like terms, okay? So when we have like terms, that allows us to actually combine. So let's look at basic. We have these two examples here, 5x plus 6x. So essentially it's like if we have 5 plus 6, Well, clearly those are like terms, so it's an 11. So then if we added x onto them, they are still like terms because everything behind the coefficient matches. Well, you do the exact same thing as you would when you have basic numbers. It is still a combining of those coefficients of those numbers. So the x's just stay x's, and you combine the coefficients to make 11x. So 5 apples plus 6 apples equals 11 apples, right? But if it was 5 apples plus 6 oranges, what would happen? Nothing. It's just 5 apples and 6 oranges. I cannot combine them to create anything. Okay? So that's combining like terms. All right, so let's look at this. All right, so 10y squared plus y squared. So these are like terms, right? So what are we looking at? We're looking at a 10 plus a 1, so 11y squared. All right, next. 9n squared minus 5n squared plus n squared. So everybody's a like term here. So 9 minus 5 is a 4. 4 plus 1, 5n squared. 7x minus 3x, 4x. All right. All right, let's look at this. 8x squared plus 2x minus 3x. All right, so 8x squared plus 2x minus 3x. So what are our like terms? Well, we have x squared, we have x, and we have x. So these two are like terms, right? So 8x squared, and then my 2 minus my 3. Remember the sign of the number is in front of it. So a positive 2 and negative 3. So a negative 1x. So we can really just write it as negative x. Okay? All right. Next thing we want to do is look at the distributive property. So here we have the distributive property, which as you can see shows A times B plus C. So what we're doing here is our outside value is distributing, all right, distributing over multiplication, distributing to everything inside the parentheses. So let's look at this, 4 times x plus 3. So what are we doing? We're distributing this 4. All right, so here 4 times x, what is that? Well, it's a 1x, right? It's a 1. So 4 times the 1 gives us 4. The x is just going to follow, and then 4 times the positive 3 is a positive 12. When you look, there's nothing that can combine, so you are finished with the problem. Okay. So the Indiana Pacers that you heard Miles Turner say, 5 straight first round exits, 3 of those. So negative 2 times 4y minus 8, right? So if we distribute negative 2, we get negative 2 times 4 is negative 8y. Negative 2 times negative 8 is plus 16. So pay attention to your signs, all right? So there's nothing else that can simplify, so we're finished. All right, so what we want to do here, we have 2 sets of parentheses, right? So in our first set of parentheses, this 3 is going to distribute. Realize that it can only distribute to what is in the parentheses only. Then we have a subtraction symbol or minus with 4x minus 1 in parentheses. So the only way we can get rid of the parentheses essentially is for us to perform the multiplication. Well, what is the multiplication when there's no value showing outside of the parentheses? Well, just like on the term, when there's no value visible, it is an assumed 1. So this is an assumed negative 1, which is going to distribute to everything in the parentheses. So we would look at 6x 3 times negative 3 is negative 9. Then we're distributing this negative 1 here, right? So we're going negative 1 times 4x is a negative 4x. Negative 1 times negative 1 is a plus 1. So we want to combine like terms. So 6x minus 4x is what? 2x. Negative 9 plus 1, negative 8. All right, so what are we looking at? We have unlike terms. Problem is finished. Problem is finished. All right, let's go again. Negative 3. Negative 3 times 2x minus 5 minus 6x. So negative 3 times 2x minus 5 minus 6x. So we want to distribute. So the distribute of the negative 3. So we get negative 6x plus 15. And then the negative 6x just comes down. Remember, it's not in parentheses, so we can't distribute to that negative 6x. You got to pay attention. So then we want to combine like terms. Well, negative 6x minus 6x. So that would be a negative 12x plus a 15. These are not like terms, so we're finished. All right, so here we have 14 minus 11 times 5n minus 6. So what we want to do here is we want to distribute, because we have to deal with our parentheses first. So what you can't do is 14 minus 11. That is not correct. That is not following order of operations, which says you should do parentheses, exponents, multiply or divide, then add or subtract. So we have a multiply option that we must take. So the 14 comes down. Negative 11 times 5n is negative 55n. Negative 11 times negative 6 plus 66. So do we have like terms? We have a 14 plus a 66. Please realize that this 55, negative 55, that negative belongs to the 55. The sign of the number is in front of the number. So the 66 is a positive. So we add those, and we get 80 minus 55n, and we're done. All right, and that is simplifying algebraic expression.